first of all, the first topic which we are going to start atom. So what is atom? It's the smallest particle. Okay. Smallest particle which cannot be divided. Okay. So you can say which can't divide it. That's fine.
Yes, sir.
Okay, so it has this atom has two parts. Two parts. The orbital part. Orbital parts, or you can say that's the orbital part, and the second one is nucleus part, or centered part, you can say.
Yes.
This atom has three particles. The electron, the proton, and the neutron. This electron is negative charge, proton has positive charge, and their magnitude of charge is equal. That is 1.6 into 10 raised to power minus 19 coulomb. And it will be given in formula sheet, okay? That's fine.
Okay.
So you don't need to memorize it. And this neutron has zero charge, means no charge, okay? But the mass of proton is approximately equal to mass of neutron. That's fine. So we can
Yeah.
say that approximately these both masses are 10 raised to power minus 27 kg. The exact value, I will write the exact value. If you say, okay, approximately these both masses is 1.67 into 10 raised to power minus 27 kg. That's fine. But the mass
Yes.
of electron is approximately 1 over 1836 times of mass of proton, okay, smaller than proton. That's fine. So the mass of electron is approximately, that is 9.11 into 10 raised to power minus 31 kg. Yeah, it's fine now.
Yes, sir.
Okay. So we can say that the electron has atom has a structure, like it is considered to be spherical structure, considered to be, okay, spherical structure, where the centered part is considered to be nucleus. Yeah, it's fine.
Yes, sir.
And this center part is contain proton and neutron. And the electron is revolving around that nucleus. So we can say that the nucleon numbers or atomic mass is, which is denoted by A, is basically sum of proton plus neutron. It's fine.
Yes, sir.
And the next thing is basically charge number, or you can say atomic number. In some books, they have written atomic number That will be denoted by Z, which is the number of proton. This
Yeah.
is very important. One of the MCQ is coming on it, okay?
Okay, sir.
And it's very easy, but it's important. Then the next thing is that at normal condition, atom is neutral. That's fine. So
Yeah.
what do we mean by neutral? So neutral means number of electrons is equal to number of protons. It's fine. So this is
Yes.
considered to be neutral. Now, experiments like Rutherford experiments, you have a study, I think, in chemistry. That's a Rutherford experiment. Have you heard about
Yeah, yeah.
Rutherford have done the experiment of golden foil experiment? So let you discuss that experiment little bit, okay? It's not in the syllabus, but we have to discuss it, okay? So Rutherford experiment is basically gives the structure of atom,
Mm.
structure of atom. So so okay. Let's ignore the experiment. Let's write the structure. What is the observations? Because the observation is coming into paper. So first observation that most of the atom is empty. This is first observation. Second observation, the center part of atom is positively charged. It's fine.
Mm.
And that the third is that mass is concentrated
Mm-hmm.
at the center, at the center of atom. It's fine. These are the observation. It is found by the Rutherford, which had done the experiment on the gold foil, okay, and throwing some alpha particle means positively charged particle. It's fine.
Yeah.
Now, if you see the periodic table, in periodic table they have written Z and A. For example, consider to be carbon, so that is 6 and 12. So basically Z is equal to the charge number, which is 6, and atomic mass is at 12, okay? So if I told you that find the neutron number, find the neutrons, then what you will do? You will, for the neutron, atomic mass is subtracted from the charge number, okay? So you get Z minus 6, that come out to be 6. That's fine. So this can be,
Yes, sir.
question can be possible into the paper. So this is something about the atom, okay? Now, let's coming to the shape of the atom and the size of the atom, okay? Okay.
Yes, sir.
Have you noted that?
Yeah.
Okay. Now, let's first discuss shape. So shape of atom is considered to be spherical. So it's why we consider to be spherical, because it is easy for the calculation. Like if you want to find the density, density of atom. So what you will need, you need density is equal to mass per unit volume. It's fine. Now, you know the volume of atom, that is 4 by 3 pi r cube. So if you put here, you get that is density is equal to m divided by 4 by 3 pi r cube, or you can write that density is equal to 3 by 4 m divided by pi r cube. It's fine. So
Yeah.
with the help of this formula, you can find the density. And we will use this formula somewhere and somewhere in the isotopes question. Okay. Now,
Mhm.
now this is the shape of the atom. The next is the size. Now, the size of atom is approximately 10 raised to power minus 10 meter. So there is an atomic unit is used, unit for the size, that is angstrom. Angstrom. Have you heard about angstrom? Angstrom. Okay. Angstrom is a unit at the atomic level, and 1 angstrom is equal to 10 raised to power minus 10 meter. That's fine.
Yeah.
So the atomic size is approximately 10 raised to power minus 10 meter. Uh, in some marking scheme, they have written approximately 10 raised to power minus 10 meter or 10 raised to power minus 9 meter. Okay. In some marking schemes, not in every. Okay.
Yeah.
That's fine.
Mhm.
Now the nuclei size. Now, the nuclei size is definitely it is a smaller part of the atom, and we have written that
Yeah.
mostly part is empty. That is approximately equal to 10 raised to power minus 15 meter. Okay,
Yeah.
but in some marking schemes, they have written 10 raised to power minus 15 meter or 10 raised to power minus 14 meter. So if the questions come and they want to tell you that find the ratio of density of atomic atom and nuclei for same element or same atom. It's
Yes.
fine. So then
Mhm.
that's your choice. Either you can use the pair of 10 raised to power minus 9 and 10 raised to power 14 minus 14, or you use the other pair. But don't use the cross pair, okay? Let me solve that question for you. The atomic density. Now, the atomic density will be equal to, this is the question which is coming in paper 2, okay?
Yeah.
So, the atomic density is equal to mass per 4 by 3 pi r cube. So that R cube is for atom. That's fine.
Yeah.
Okay. Now the nuclei or the nuclear density, which is approximately for the nuclei, is m divided by 4 by 3 pi r cube. for the nucleus. Now masses are same, pi is same. Now we will take the ratio, atomic ratio divided by nuclei ratio. So what we get? Mass divided by 4 by 3. Oh, sorry. Yeah, it's correct. 4 by 3 pi r a cube divided by m divided by 4 by 3, 4 by 3 pi r cube into nuclei. So everything will be cut down except radius. Okay.
Mhm.
So we get this as a Rn cube divided by Ra cube.
Yes.
Fine. Now, if we take the whole cube, like Rn divided by Ra whole cube. So it means you will put the value here. You get 10 raised to power minus 15 divided by 10 raised to power minus 10 whole cube. And you get 10 raised to power minus 5 whole cube. And approximately you get 10 raised to power minus 15. This is the
Yes, sir.
ratio you get it. If you take the other values, like 10 raised to power minus 9 to 10 raised to power minus 14, you get the same ratio, okay? You get the same ratio. So
Okay, sir.
if you want to do in the other way, like that is, if I put it nuclei and atomic, the other value which is given in marking scheme, that is 10 raised to power minus 14 and 10 raised to power minus 9. So you will get the same ratio. Okay, you'll get the
Yeah.
same ratio, that is 10 raised to power minus 15. That's fine.
Yes.
So if the
Yes.
questions come into the MCQ, that how much the difference between atom and nuclei. So you can write that atom density of atom and nuclei is equal to 10 raised to power minus 15, means atom is 10 raised to power minus 15 than the nuclei, or the nuclei is 10 raised to power minus 15 times plus 15 times of 10 raised to power atom. So the nucleus is denser as compared to atom size. Have you observed that?
Yes, sir.
So how much it is denser? 15 times denser than the nuclei size.
Yes.
That's fine. So these
Mm-hmm.
are the some of the basic things which they ask in the paper about only about the atom. Okay, that's fine.
Okay.
Okay,
Yeah.
now we coming toward another terminology, and you know it that very well. Have you noted that?
Yeah.
Okay. The next terminology is the isotope. You know isotope
Yes, sir.
because you have
It's the
also study in the
yes.
chemistry.
Uh-huh.
Yeah. So isotope is that
Same element with the different number of neutrons.
same proton number, or you can say same atomic number, or you can say same charge number. So all these wording can be used in the paper, okay? But different neutrons number, new, okay, sorry, neutrons number or different nucleon numbers or different mass number, atomic mass, okay, atomic mass. It's fine.
Yes.
So these all wording can be written in the paper. Okay, just remember these all things are the same. Okay. So anyone, any of the definition you have to remember, so it will be correct. It's fine. So like, for example, uh, carbon. Carbon 612 has two isotopes that I know, that carbon 614 and the carbon 613. It's fine. Similarly, hydrogen has two isotopes, that is deuterium and that is tritium. That's fine. So if
Yeah.
you see in these in both examples, the nucleon number is going to increase, but the charge number or the atomic number remain the same. That's fine. Yeah.
Yeah.
Remember that. Remember one thing, that this thing I will be going to repeat again. Okay, but here I just want to say that in in particle physics, all conservations laws must be obeyed. It's fine.
Yeah.
And there are four laws of conservation. That is conservation. That four laws are, sorry, I can write again. So conservation of momentum, conservation of energy, conservation of charge, and conservation of nucleon numbers or mass number. It's fine.
Yeah.
So whenever you study the particle physics or you writing the equation for the particle physics, all these conservations laws must be obeyed. Okay, when we are going to study the reactions, especially nuclear reactions, especially these conservations are laws is considered to be nuclear reactions. Okay, nuclear
Yeah.
reaction, like in your chemical reaction, if you remember, you obey just two laws. One is a charge and one is a mass. Okay. You have to keep in mind that your charge on the product side and the reactant side will be the same. And similarly, your mass and the product side on the reactant side will be the same. Okay. So that's it. You got it. That's fine. Yeah. Yeah. Either. Okay.
Yeah, it's fine.
Okay. Have you noted?
Yeah.
Okay. Now we have the topic radioactivity. Radioactivity. So what is radioactivity? So the definition is that the spontaneous emission of invisible particles from unstable nuclei. From unstable nuclei. Okay.
Okay.
Tell how, when it will reaction is stop. Tell the nuclei become stable. The nuclei becomes stable. This process is called radioactivity. The element using in this process is called radioactive element. That's fine.
Yes, sir.
There are two types of radioactive element. First one is natural radioactivity or natural radioactive elements. So the elements more than more than 82 means the charge number is more than 80, sorry. That elements are called natural radioactive elements, okay? But second one is artificial radioactive element. Artificial radioactive
Element.
elements. So those elements which produces invisible radiation by means of electric or magnetic fields. That is called artificial radioactive element, and it is less than 80. Okay, it is less than
Okay.
80. Now, the radioactive process is spontaneous. Sorry, spontaneous. Spontaneous and random. So what do you mean by spontaneous? Spontaneous spontaneous process means that this process will not be affected by environmental conditions, or you can say physical conditions. Okay,
Yes, sir.
what do you mean by physical condition? Like temperature, pressure, chemical reaction, and electric and magnetic field. Electric and magnetic fields. These things will not affect, okay? These things will not affect, okay? Not affect the spontaneous emission, means radioactivity process, okay? So this is called spontaneous emission. It's fine.
Mm.
Now, what do you mean by random? Have you noted that?
Yeah.
Okay, so random. What do you mean by random process? A random process means cannot predict by space and time. So what do you mean by space?
The
Space
area
means
in the envelope
exactly,
that is not taken up by the nucleus.
exactly the direction of emission, okay, cannot be predicted. Cannot be predicted. Okay. And what do we mean by time? So the number of particles emitted, how many and how much in the given time. So you cannot predict, okay? Cannot predict that how many particles will be emitted from that material, okay? That's fine. So you cannot
Yeah.
predict about it. Okay, one thing I just forget it about the isotopes. So that's coming into in MCQs that isotopes, the isotope that in which chemical properties remain same, remain same, but the physical properties will be changed. Okay.
Mhm.
I will give you the example like if you take water, H2O, which is made from the temperature. Now, this H2O and this H2O. Now, this is the I called pure water and this I called heavy water. The chemical formula for the both water will be the same. But if you want to measure the boiling point of the both water, that will be different. Okay. So the chemical formula will remain same, but the boiling point will be different. That's fine. So this is known
Yeah.
as that the chemical properties will remain same, but the physical properties is going to change. Okay. Now,
Yeah.
coming toward these invisible particles. So there are three types of radioactive particles. You know that three types. You know
Alpha, beta, and gamma.
exactly. So let's discuss alpha particle. First, alpha particle. So first of all, number one, alpha particle is just like helium atom. Okay, helium. So it means just like a helium means He2 and 4. What do you mean by just like atom? Number two, its mass is 2 4U, where the charge is positive 2E. That's fine. So we can say it is heavy positive charge, okay? Heavy positive charge. Number three, because it is a fatty particle, so that's why the speed is less than speed of light. It's fine.
Mhm.
Its speed is approximately not written exactly somewhere, but somewhere 10 less to power minus 7. Okay. Oh, sorry, not minus
Okay.
7. 7. Sorry. Not minus 7.
Okay.
Sorry. Sorry. Sorry, just out. That's a 10 less to power 7. Approximately. Okay. Fine. Yeah. You want to say something? Either.
No, sir.
Okay. So fourth thing is that because it is a fatty particle, means it's a heavy particle, so its penetration power is very less. Do you know penetration power? What do you mean by penetration?
Like depending on like what the greater the penetration power, the more type of like surfaces or objects it can move through.
Exactly. So passing through how much it can passing through the object. So because its penetration power is less, so it cannot pass through the more thick material. Okay. So in air, it is goes to the few meters, but it is blocked by paper. So the alpha particle can be blocked by the paper. Okay, it's fine.
Mhm.
Now the fifth point is that because it is heavy positively charged, that's why it's ionization. Do you know that ionization?
Yeah.
Ionization is very high. Have you studied in chemistry? I think you have a study in chemistry.
Yeah.
Okay, that's good. And number six, it's deflected by electric and magnetic fields. That's fine. So deflected by magnetic means if you throw the particle into electric field, this alpha particle, the alpha particle will be diverting toward the negative plate. Okay, so it will be affected by negative and sorry, magnetic and electric field. Okay, that's fine.
Yeah.
Now let's discuss the beta particle. Now the beta particle, number one point, not exactly, okay? Just like electron. So electron means minus one charge. So it means its charge is minus 1 E or minus E, but it is massless particle, okay? Approximately massless particle. That's fine. So because it is
Yeah.
approximately massless particle, so its speed is approximately, not exactly, okay? Approximately speed of light. That's fine.
Yeah.
So because it is a light, so its penetration power is high. How
Yeah.
much high? In air, it can be moved to the 100 meters, 100 meters, and it can be blocked by lid. I think lid. Let me confirm that, but I think it is lid. Okay.
It's aluminum.
Yeah, thank you very much. Thank you. Thank you. Because I just forget that point always.
Uh,
That's
the list
aluminium.
for the third one.
It's a 2 millimeter, up to 2 millimeter. It's fine.
Yeah.
Okay. So fifth one is it can ionized. Ionization is not very high, but high. Okay. Ionization is high, not very high. And number six, because it is a charged particle, so it can be deflected by electric and magnetic field. And magnetic field. That's fine. Now this is the beta. Now let's discuss about the gamma now. Gamma particle. Yeah, Heather. It's fine.
Yeah.
So gamma is high frequency electromagnetic radiation. That's fine. High frequency electromagnetic radiation. Number second
Mhm.
point. It's a chargeless and massless particle. Number three, it's moving with the speed of light. Speed of light. Exact speed of light. Number four, its penetration power is very high. Penetration power is very high because it is a massless and chargeless. In air, it
Mhm.
is in 100 kilometers. In kilometers, it can be travel and it can be blocked by lead up to 5 millimeter. Okay. So number five, no ionization. Why no ionization? Because no charge is there. Okay. So that's why no ionization. And number six, no deflection. Why no deflection? Again, because the no charge is there. So that's why no deflection can be possible. It's fine.
Yes.
Yeah. So this is the basically major differences. Okay. We have to study. Maybe sometimes a question will become MCQ question can become on these points. Okay. Not in the subjective, but MCQ can become on these points. Okay. It's fine. Yeah. Have you noted that? Yeah, Heather. Hello. Hello. Can you? Hello, Heather.
Hello, sir. Yes.
Sorry, I just lost the signal. How much you have noted?
The whole thing. I got the whole picture.
Oh, that's
I
thank
wrote
God.
everything.
Oh, thank God. So just I uh, that uh, just I